Hi guys, today me, Aiman and my friends are going to share about the importance of theory of thermodynamics in nuclear power plant. This video project is the result of collaboration between me, Muhammad Aiman Haikal bin Hamidun, Nik Muhammad Haikal bin Mak Hassan and Muhammad Hafizuddin bin Ramli. Introduction. What is nuclear power plant? A nuclear power plant, NPP, is a facility that generates electricity by harnessing the energy released from nuclear reactions. It operates on the principle of nuclear fission, where the nucleus of an atom is split into two smaller nuclei, releasing a significant amount of energy in the process. The core component of nuclear power plant is the nuclear reactor, which contains fuel rods composed of radioactive material, typically uranium-235 or plutonium-239. What are the objectives of this video? Firstly, we want to explain the fundamental principles of thermodynamics and its relevance to the first law and second law of thermodynamics in nuclear power plant. And secondly, we want to show the application of thermodynamics theory in optimizing efficiency of the operation of nuclear power plant. Okay, now we go to the first law of thermodynamics. What does the first law of thermodynamics say? It says that energy cannot be created or destroyed. It can be only converted from one form to another. In the context of nuclear power plant NPP, the first law of thermodynamics is crucial in understanding and analyzing the energy conversions and transfers that occur. Now we move to the application of first law of thermodynamics in nuclear power plant. The first application is nuclear fission. In a nuclear power plant, the first law is applied to the process of nuclear fission. During fission, the nucleus of a heavy atom such as uranium or plutonium is split into two smaller fragments, releasing a tremendous amount of energy in the form of heat. The first law ensures that the total energy released during the fission is accounted for and is converted into useful forms such as electrical energy. The next application of the first law of thermodynamics in nuclear power plant is heat transfer. The first law is essential in understanding the heat transfer processes that occur in a nuclear power plant. After the nuclear fission, the released heat needs to be transferred from the fuel elements to a working fluid, typically water, to generate steam. The first law ensures that the energy gained by the working fluid is equal to the energy lost by the fuel elements, accounting for any losses due to the radiation, conduction, or convection. The next application is steam cycle. Nuclear power plants use steam turbines to convert the thermal energy in steam into mechanical energy, which is further converted into electrical energy by generators. The first law is applied to analyze the energy transfers and conversions that occur within the steam cycle. It ensures that the energy input to the turbines matches the energy output from the condenser, accounting for any losses due to friction or inefficiencies. The next application is electrical generation. The first law is also relevant to the electrical generation process in a nuclear power plant. It ensures that the electrical energy produced by the generators is equivalent to the mechanical energy input from the turbines. The first law helps track the energy flow from the nuclear fuel to the final electrical output, accounting for any losses that may occur during the conversion process.
Thank you, Aiman. Now, my name is Muhammad Hafizuddin bin Ramli. Now, I will present to you guys about second law of thermodynamics. Basically, we know that second law of thermodynamics states that heat will always flow from a hotter object to a colder one, and it is impossible to convert all heat into useful work without some energy loss. So, the second law of thermodynamics in the context of a nuclear power plant states that it is impossible to convert heat energy completely into useful work without producing some amount of waste or heat transfer to a colder reservoir. So, this law established fundamental limitation on the efficiency of energy conversion processes within the plant. So, for the energy conversion in nuclear power plant, thermodynamic principles are applied to convert the heat energy released from nuclear fission reaction into electricity. So thermodynamics provide the theoretical framework to optimize this energy conversion process and maximize the efficiency of power generation. Now, for efficiency optimization, by applying thermodynamics principle, engineers can analyze and improve various components and processes within the power plant to enhance overall efficiency and minimize energy loss. This is the energy conversion in nuclear power plant. So, below this is the step in converting energy as follows: from nuclear energy to thermal energy to kinetic energy in steam, and kinetic energy in steam to the kinetic energy in turbine. Okay, this is thermodynamic efficiency. So this is the meaning of thermodynamic efficiency. Can read it. Okay, waste heat management. So during the process in the nuclear power plant, it generates significant amount of waste heat. So by using the thermodynamic principles, they manage to dispose of this waste heat effectively. Various cooling mechanisms such as cooling tower or bodies of water are designed to dissipate the excess heat without impacting the environment negatively. Thermodynamics provide the framework for optimizing these cooling processes and ensuring the safe and responsible management of waste heat. The nuclear power plant has advantage and disadvantage. First, we go to advantage. As we said, the fuel consumption in this power station is quite low, and hence cost for generating single unit is quite less than other conventional power generation method. A nuclear power station occupies much smaller space compared to other conventional power station of same capacity. Third, this station does not require plenty of water, hence it is not essential to construct plant near natural source of water. And now for the disadvantage of nuclear power plant. So the fuel is not easily available and it is very costly. So second, initial cost for constructing nuclear power station is quite high. Third, erection and commissioning of this plant is much complicated and sophisticated than other conventional power stations. The fission byproducts are radioactive in nature and it may cause high radioactive pollution. So, the maintenance cost is higher and the manpower required to run a nuclear power plant is quite higher since specialty trained people are required. So 6. Sudden fluctuation of load cannot be met up efficiently by nuclear power plant. So that's all from me. Thank you. Now we go to Nik Muhammad Haikal.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Nik Muhammad Haikal bin Mat Hassan. So I'm going to explain about how nuclear power plants work. So based on the picture, we can see that the steam is produced by heating the water. So the steam will spin the turbine and produce electricity. Water is heated during nuclear fission using heat. During nuclear fission, in the reactor core, the steam was created by heat the water to the boiling point. The rotation of turbine blade will drive electricity generating generator. Nuclear power plant may use water from pond, river or ocean, or they cool the steam back into the water in separate building, or we call condensation process at the power station called a cooling tower. After cooling, the water is used again to create steam. Safety consideration. Effective security measures are required in addition to accident management technique or sabotage and to safeguard sensitive data. An approved security plan is required for every plant. Each plant must adhere to security requirements, both for the plant themselves and the transfer of radioactive material. and this is the responsibility of Office for Civil Nuclear Security. So for future development in nuclear power plant may utilize advanced reactor design such as generation 4 reactors, which aim to achieve high thermal efficiency and improve safety features. This design include advanced concepts like molten salt reactors, high temperature gas-cooled reactors, and fast neutron reactors. So for the conclusion, thermodynamics play an important role in nuclear power plant. The application of thermodynamic principle law are relevant to energy conversion, heat transfer, and work are fundamental to understanding and optimizing the efficiency of these facilities. By harnessing the principle of thermodynamics, we can optimize efficiency, increase power generation, and ensure the safe and efficient operation of nuclear power plant, contributing to a cleaner and more sustainable energy future. So here are some of our reference to do our assignment. That's all from our group. Thank you.